Hi there everyone and welcome to Choose a Channel Name. So let's be honest, if you're here right now, you're probably stuck somewhere between a compiler and a command not found error message. Don't worry, I've been there too. And I'm here to help you out of the dev gutter with a simple, clean setup. So in this short tutorial, I'm going to walk you through how to set up your Linux environment using Ubuntu on WSL2, an assembly function. We'll install the tools you need, explain each step clearly, and by the end, you'll not only run the code, but understand exactly how it works line by line. So quickly go grab a coffee, open your terminal, and let's get your low-level programming dreams up and running.
That's great!
So first of all, you're going to start up your PowerShell and open it in administrator mode. Just get past this prompt, yes. And from there, I'm dragging down this PowerShell. I'm going to paste in some commands. These PowerShell commands that we're going to paste in now is to enable the necessary Windows features that will allow WSL2 to function properly. I'll add them to the description below so you can just copy and paste along. After they finished running, you're going to need to restart your PC. See you back in a sec.
75 years later.
Up next, we're going to need to install Ubuntu. So we're going to head on over to our Microsoft Store. We're going to search for Ubuntu latest version or newer, which is going to be, for the sake, 22.04. We're going to hit the install button and just wait for that to finish up.
Wait for it.
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 Wait for it. Keep waiting. Wait for it.
Once that has finished installing, we're going to hit the open button and that will open up this console right here. I'm just going to drag this WSL console down. Now we just wait for that to finish up. It may take a while, so just wait for it to finish up. Once you see this enter new Unix username, you know that it's finished. And we're going to continue on that. So enter your username, then enter a password. Going to need to verify that password. Great. Now with the following two commands, we're going to install our development tools inside of Ubuntu. So first we're just going to update it. Then after that, we're going to install NASM. Enter our password here. Just wait for this install to finish again. Let me just speed this one up again. Great. Now for NASM. Okay, great. With everything now ready to go, here's my file explorer. I'm going to click here, clear that out, and then let's go into the WS folder. So we're going to go whack wsl.localhost. I'm going to press enter right there. There you can see we've got Ubuntu 24.04. We're going to head in there. From there, I've got home, then my username that I used. That's a folder created right there. And as you can see, this is our standard layout. So this is where we're going to save our project folder. And whenever we're working and stuff like that, we're just going to reference it from here. So let me just get that out of the way. Okay, so back in our console, what we're going to do is we're going to add a projects folder. So we're going to use mkdir for make directory // projects, and inside that directory or that folder, we're going to create another folder that's going to house our little project that we're going to do. We're going to call this project ASM check, which I will explain a little bit later on. So let's create that, and then I'm going to bring down File Explorer again. So let's just go home, back in here, and then you can see here we created projects, and we did create that ASM check. So taking that out of the way again, what we can do, for example, you can also do cd, which is going to change the directory, and we're going to go into that projects folder, and inside the ASM check folder. There we go. Okay, next up, so just to keep this a little bit simple, personally I like working in VS Code, so I'm just going to right click right there and I'm going to open this in code. Can minimize that right now. Just bring back down code right here into our little window. There we go, that looks about right. So if we click there, let's check it out. So as you can see, we are in ASM check, and in here we are now going to code our little project. Okay, so for our coding project, I've got this little project ready to go that I'm going to explain to you after we've added all the code. So I'm just going to copy and paste this over because, like I said in the beginning, I just want to keep this short and sweet. So I'm just going to go new file. I'm going to call this file check.asm, and I'm going to create another folder. I'm just going to call this one main.c. Okay, so we've got one assembly and we've got one C, as with the title of the whole thing. So first up, let's go in the C. I'm just going to paste this in right here, save that out. You can pause here for a second if you want to start typing this out. I'm going to head on over to add check again. I'm going to copy that over, save that over, and there we go. Now for a quick explanation of what's going on here. Okay, so in this program, it demonstrates calling an assembly function from C. The C code begins by including the standard IO header, then declares the external assembly function check and add. In main, it sets input to 3, calls check and add function with input, and then stores the result in result and prints it out using printf. So the assembly code defines the check and add function in the .text section, which is right here, and it marks the global so that it can be linked with C. When the function is called, the integer parameter, which is n, is passed in the RDI register as per the system. So this code compares the RDI to the 3 using CMP, or compare RDI 3. So the code compares the value in the RDI register to 3 using the CMP RDI, 3 instruction. So CMP stands for compare. It performs a subtraction, which is RDI minus 3 internally, but doesn't store the result. Instead, it sets the CPU flags based on the outcome, such as 0, sign, or carry. So if the values are equal, the 0 flag is set and the program jumps to the is.is3 label using the JE instruction. Now JE stands for jump if equal. So that sets the EAX register, where EAX is used to return values from functions, to 4, and then basically just returns the program then from there back to C. If the values are not equal, the code sets EAX to 1 and returns immediately. So in summary, the function basically just returns 4 if the input is 3 and 1 for any other inputs. Yeah, I know it sounds weird, but that's what's the first project idea that popped into my head, so enjoy it while you can.
Genius. Let's do this.
Okay, now to compile and run and test this code out, I'm just going to take this away here and I'm going to pull down our console again. There we go. So within this, I'm just going to go there. We've got a clean one so it looks a little bit prettier. Okay, so like I said, I'm not going to be wasting any time, so I'm just going to copy and paste over these lines I've got prepared, and then I'm going to explain to you what each one of them means. So let's go with the first one. Here we go, second one. And now for our third one, I'm just going to type this one out, so it's just ./program like we've got there. There we go. As you can see, it prints result for assembly equals 4. Now, so the first two commands are used to assemble, compile, and run a program that combines assembly and C code on a 64-bit Linux system. The first command, which is nasm-f elf64, that one right there, uses nasm or netwide assembler to assemble the addcheck.asm file into a 64-bit object file, which is of course addcheck.o, using the elf64 format, which is standard for Linux executables. So it's definitely good to remember for tests and exams and all that stuff that's coming up, because you're going to be working with it quite a lot. The second command, which is gcc-pi-no-pi and so forth, tells GCC or the GNU-C compiler to compile the main.c and then link it to the addcheck.o to produce an executable named program, and program is the one that we launched there at the end. The -no-pi option ensures that the output is a traditional executable rather than a positioned independent one, which is necessary when working with simple assembly code that expects fixed addresses. So the final command, again ./program, was used to run and compile the program from the current directory. And as you remember, let me just pull down our VS Code here again. As you can remember, like we said, we compare the RDI3 and then we jump .to is3 if it is true, so then it moves to the 4 to the EAX, which got returned at the end of the day because 3 was passed successfully through. If you go back here to main, which was the input that we sent here through there. So yeah, yeah boy, and that's it. You've just set up your environment, you've written some assembly, and you've called it from C and ran it in Ubuntu using WSL2, all from your Windows machine. If you found this helpful, give me a like. Don't bother subscribing, this isn't one of those channels. If you're more into low-level coding or dev tips, please let me know in the comments. Maybe in the future I'll start looking into maybe making a little bit more of these videos. Trying to get my knowledge out there, but at this point this is just to help a few people out that I've noticed struggling in the past. So yeah, great, thanks everyone and have a beautiful day.